We're live. Hello. Sorry, Nathan was starting to talk, but welcome back to another episode of Containers from the Couch. Nathan, since you were talking and I rudely interrupted you, do you want to start with an intro?
No problem. My name is Nathan Peck. I'm a developer advocate on the container services team at AWS, and this is Containers from the Couch. And this is also our monthly roundup where we're going to get to talk about a lot of the blog posts, new releases, fresh announcements from ECS in this past month. And it's also a little bit of a containers office hours. If you have questions about containers, questions about ECS, hit us up in the chat. We're always happy to chat with you, our audience, and our users of containers on AWS.
We actually already have a question right now. Containers like Docker. Yes, Docker containers. You can also, we work on ECS or Elastic Container Service, which is AWS's container orchestrator. You can use Fargate EC2, but Nathan and I both come from container world, container background, so feel free to ask us anything. And for the record, hi everyone, my name is Jessica Dean, and I am also a developer advocate here at AWS. And we have actually quite a few things that happened in March. We have about 7 different announcements. It was a busy month. Let me go ahead.
As it always is.
As it always is. We're always innovating and doing things here. Looks like the first thing that the first announcement that we have to talk about today is autoscaling Amazon ECS services based on custom metrics with application autoscaling. Now, autoscaling, I think, is a passion. I don't want to, maybe that's the wrong word, but I think that's something Nathan is in particularly very passionate about. I've heard some of your talks about that.
Yeah. So this is an interesting one because if you've used ECS, you know that sort of out of the box, ECS gives you certain metrics for your application. ECS is constantly monitoring your application containers, gathering up stats like its CPU, its memory, and pushing those into CloudWatch for you on your behalf. And if you've used like the console or some of the other integrations with ECS, there's sort of pre-built patterns for saying, I want to scale my application based on that CPU utilization or based on memory or something like that. Well, so what this blog post is talking about is what if you have an application that's not easy to understand the scaling metrics for? So you can't just use like the built-in telemetry that ECS is pulling out of your application because there's something else you actually have to understand about how the application functions or what's doing internally to understand whether it's time to scale it out. And that's still possible to scale an ECS service based on custom metrics. This blog post just talks about how to go about setting it up and making that work.
How would you configure and wire that? Yeah, this first little sample figure display, you can see that you have within Amazon ECS, you have your 3 different services, you have your backend data store, and then it looks like you also have a CloudWatch agent and your ADOT collector that's sending custom metrics over to CloudWatch. Now, for anyone who may be new, Nathan, do you want to do just like a brief overview of Amazon CloudWatch and how that integrates with containers from a logging and metrics perspective?
Yeah, so Amazon CloudWatch is basically a serverless store for your metrics and telemetry. You don't have to ever worry about scaling CloudWatch or anything like that. It's just you get charged based on your usage, how much metric data you're pushing in and querying out, how much log data you're pushing in and querying out. But it also integrates with CloudWatch alarms, which allows you to set up rules that trigger when it sees certain things in those logs or those metrics. So if it sees a metric breach a target that you've set, let's say 80% CPU, if it sees your CPU goes over 80%, it triggers that alarm, and that alarm can be hooked up to other actions such as application autoscaling, which then has built-in rules that you can set up. It has some built-in behaviors and some things you can customize to say, when I see this particular scenario, I want you to react by telling ECS to scale out 1 task, 2 tasks, 3 tasks, however many tasks you want to scale out, or scale out a percentage of tasks in response to this scenario that it noticed inside of the logs and metrics.
That's pretty cool. So now you can kind of really automate your scaling, and rather than just having to react when you see that particular alarm go off in CloudWatch, your application auto scaling will now handle that. for you.
Yeah, and I want to talk about one reason why you might need to use like a custom metric, because most of the time the CPU and memory is a very good proxy for your application being too busy. But one of the things that I've noticed is there are certain workloads, like for example, let's say a WebSockets workload, where you have very long-lived connections, and the connections aren't necessarily busy, so they won't necessarily always be pushing your CPU and memory, but you want to limit how many connections are going to each backend. So that might be a scenario where you have your application publish a custom metric that says, I currently have 1,000 connected clients connected to this backend. And so you're able to look at an average of how many connected clients are there per backend and say, if I see that number start to get too high, it's time for me to add some more replicas to my service, so that way I don't have just too many people connected to each of these backends. So that's an example. You can wire that up.
It balances it out. It's very helpful, and it's awesome now that you can have that based on your custom metrics. You can program that into your existing architecture.
Mm-hmm.
Another announcement we had is AWS Copilot officially has added support for full customization with AWS CDK or YAML overrides. And CDK is Cloud Development Toolkit, and it is the way that you would programmatically configure your infrastructure, your architecture. So now using Copilot, which kind of simplifies and leans into CDK, you can fully customize your CDK or your YAML with overrides as needed.
Yeah, I think this is like a natural extension of where Copilot is sort of going with. In my mind, when we first designed Copilot, it was with the goal of making it easier for you to get started with a container on AWS when you don't really necessarily know how to set that up. You need somebody who, in this case, is your co-pilot. You're in the pilot seat, but you have the co-pilot next to you that says, "Let me help you with that and figure out a route that will get us there." So you get that first container up and running, and it works great. But then as time passes, you start to realize, I want this other feature. I want this customization. As you learn more about the platform, and you start to say, Copilot can't do everything that I would like it to do. So now, what is your solution? You either have to stop using Copilot completely and start over from scratch again with your own custom CloudFormation, your own custom CDK app, or in this case, now we have CDK overrides. You don't necessarily have to do that anymore. You can use the starter template that Copilot gave you, and you can start to extend that with extra details, extra patches, extra resources that you want to put into that stack without scrapping, getting rid of everything that you already had, starting over again.
Yeah, it'll actually generate an overrides directory for you to use, depending on whether or not you're doing like a YAML patch or CDK. We see a comment from Vlad saying CFN YAML for the win. Absolutely. Yes, YAML all day, every day. And for those of you that like CDK too, we have that as well. And then that would, of course, generate your CloudFormation templates. But the benefit being that you can have full customization with overrides. So as Nathan was saying, you don't have to move away from Copilot. You can still be able to have, you can be the pilot and have your Copilot in the driver's seat with you.
Yeah, the interesting thing about the CDK overrides is I haven't had a chance to play with this yet, but it looks like it has the TypeScript support and allows you to pull in a resource out of the CDK stack as a particular TypeScript type. So I'm seeing like a syntax that says this template, get resource, the resource name as, and then the TypeScript type ECS.CloudFormation service. And so that means you get all the type bindings, and your CDK app will understand whether or not you're making a good mutation to the Copilot app or whether you're making something that makes absolutely no sense. So the raw JSON patch, like you could technically patch the YAML or JSON in a way that doesn't make any sense, adding a property that CloudFormation doesn't understand or value that CloudFormation doesn't accept. Whereas the CDK is going to give you an extra layer of validation and sort of linting built in there with the TypeScript definitions.
Well, it helps you also have like that programming language validation. So you get to rely on TypeScript to handle that, as opposed to having to make sure your JSON syntax is correct and
autocomplete in your IDE, all that good stuff.
Yeah, and then I'm assuming, I mean, again, I haven't played with it as well, but if you're not a Node developer and you are using other languages, CDK does support other languages. So I'm assuming there's also similar support for that as well when you're using CDK with those overrides. If you do get a chance to play with that, please reach out to us and let us know your experiences, give us your feedback. That stuff is always super helpful and super valuable. Our third announcement on the list is that Amazon ECS provides contextual failure reasons for troubleshooting task launches with capacity providers. Uh, Nathan, thoughts on this one? This is pretty an interesting one.
As part of an ongoing effort, I think that we've seen a lot of feedback from users of ECS that they don't necessarily always understand what's going on when there is a situation where ECS isn't responding as they expected.
Right.
And this becomes extra complicated when you have all the moving parts. So one of the ways that folks like to use ECS is they like to spin up a cluster which starts out completely serverless, completely empty. You're not paying anything for it. And when you go to run that first service or run that first task after a period of time, ECS will automatically launch EC2 capacity behind the scenes for you and place your task onto that EC2 capacity and make sure that it's running there. Now, there's obviously a lot of moving parts there. There's a lot of different things that could cause that task to be delayed to start while it's waiting for capacity. Maybe there's a capacity constraint. It's not able to launch the capacity type that you requested for some reason. So there's a lot of different scenarios that could happen with these capacity providers inside the ECS cluster. And now there's a little bit more detail in the failure reasons that you'll see in the Amazon ECS console, right, as well as in Event Bridge. Right. So if you're tying into these events programmatically, Event Bridge will also give you a more verbose explanation of exactly what ECS is doing, what it might be waiting on, or what the reason is why it might not have launched that task like you expected.
Yeah, I think that's super helpful too, because I mean, even outside of ECS specifically, but anytime, depending on whether you're from a developer background, operations background, everywhere in between, anytime we end up seeing an error message pop up and we see red text, but it's just a whole bunch of like jargon that we don't understand, it's really hard to troubleshoot, right? Like you're starting to try to go off and dig into the issue and go down the rabbit hole. And now specifically in the context of ECS, and when you're relying on your capacity providers to have that information and that context behind what failed and why, or why something's waiting, to be able to have that be a little bit more clear, simplifies that. It makes that rabbit hole a little bit easier to go down.
And I think some of the edge cases that existed before were particularly nasty ones. Like, for example, let's say you're trying to launch an ARM task and it's using the ARM capacity type, but then your capacity provider behind the scenes is providing Intel instances. So now you could be sitting there and you could have been sitting there watching your ECS service and being like, this task is never launching. Like what's the deal here? My capacity provider is hooked up. It added instances to the cluster, but for some reason my tasks aren't getting placed onto this capacity. So basically what it's doing now is it's pulling in more details about what is the mismatch or what was the reason why this task is not being able to be placed onto that capacity that was added. And hopefully it'll help folks debug some of these failure conditions a little bit faster and get to success faster without struggling for as long.
Yeah, absolutely. And for those of you that want to give this a try and want to have more of that contextual information, that experience is available in all AWS reasons, and there is additional API reference documentation to see a list of different failure reasons to help you understand exactly what's going on in your capacity providers and EC2 instances with ECS. And let's see, the next announcement, like I said, we have so many announcements. It's awesome to see. AWS Batch has launched support for configurable ephemeral storage on AWS Fargate. So this is also really cool now that you can have ephemeral storage when you're using AWS Fargate, which is, again, for those of you maybe new to ECS containers, you can run your containers on ECS using EC2, which is what we were just talking about. It's an actual instance or VM kind of running as part of your ECS cluster. Or you can have Fargate, which is the more serverless approach where you don't have to maintain or manage any of those nodes or VMs. You don't have to worry about any of that. It's just going to be scheduled. And now being able to configure ephemeral storage as part of your Fargate service, I think is a pretty big addition.
Yeah, and this is specific to being through batch. So you could already configure your ephemeral storage through the ECS API, or I think ECS API as well. But AWS Batch is an extra layer on top of the ECS API for when you have a particularly large amount of work that you want to do and you want to schedule it out over capacity over a certain period of time. Or let's say you have like 10,000 jobs that you want to farm out to 10,000 different Fargate tasks as part of like a batch workload to choke through a gigantic data set. So what was missing was sort of that integration to say from the AWS Batch side, I'd like you to configure each of the tasks that AWS Batch launches through ECS with this ephemeral storage setting.
Right. So, and it looks like there's beyond the default value of 20 gigs for your jobs. Now you can go up to 200 gigs. So, I mean, it's definitely where you're now setting the ephemeral storage ranging from 21 to 200 gigs. This is for those large jobs to be able to tap into that.
Now, I will say caveat there, be careful because look at the Fargate pricing for this ephemeral storage. Beyond 20 gigabytes of storage, you do pay for additional storage. So don't get too happy about throwing 200 gigabytes on there if you don't actually need 200 gigabytes. Right. You know, if you can't keep it in within the 20 gigabytes, you're not going to be paying anything extra for that storage per hour. But check the rates, see if that's appropriate for you. Check to see, you know, based on the job size that you're doing, if you actually need more storage and exactly how much you need.
And I'm assuming you could also, like, for those customers who are doing like machine learning and whatnot, which I feel like that would probably be where it's most useful. You can spin that up to run your ML algorithms, run your test, run everything, and then spin that down too. So you're not paying for that like long term, right? Like you want to part of cost optimization. You want to keep those costs down and only consume and use what you need, and then be able to let that job finish and kill out that infrastructure after.
Oh yeah, exactly. And that's one of the benefits of AWS Batch too. You know, if I was spinning up an EC2 instance and attaching a 200 gigabyte volume to it and just leaving that EC2 instance up and running at all times, or even a farm of those EC2 instances, each with their own 200 gigabyte volume attached to it, then I'm going to be accumulating cost constantly versus Fargate. It's only for as long as that batch job is actually running. The batch job finishes, I'm not getting charged for the compute anymore. I'm also not getting charged for the ephemeral storage anymore either.
Right. So you use only what you need, and then once it finishes, you no longer need it and you don't get charged for it. So that's a pretty awesome one there, especially, like I said, I feel like one of the biggest use cases would be for like machine learning and for when you're running those large data sets. The next announcement is implementing a pub/sub architecture with Copilot. Now, it looks like to illustrate this, you're going to create a pub/sub architecture that's based on your architecture, similar to whatever one's covered in this blog post. But rather than having to resort over to Lambda, you can actually continue to leverage ECS and AWS Fargate.
This is definitely one of my favorite architecture patterns. I've used this or some variation of it in every single thing I've ever built. The reason being that it scales incredibly well. Oh yeah, wild rides.
This is the similar architecture that they're talking about covered in this post. But I definitely love that graphic. That's a winner right there.
Oh yeah. My favorite diagram I think is where it shows what you're actually building, where there's a publisher and then subscribers. Like this particular. I believe it was on the first one. Yeah. Scroll down a little bit more on the page. Yeah, that one right there. This particular way of designing your pub/sub, I find it scales out incredibly well when you have multiple development teams, because the development teams can now work on their separate components of the end-to-end application without stepping on each other's toes and without actually even needing to be aware that another team is developing a new feature. So for example, like this publisher, is just publishing a generic event to an SNS topic. And now anybody else can create a worker service that consumes that event, and they can deploy their worker service without ever having to talk to the upstream publisher of the event to create an integration, because the integration is just something that they can create in a self-service manner with an API call to set up a subscription between the SNS topic and SKS queue. So it really decouples teams to be able to work independently and not be blocked by each other. Because imagine if there were 50 other teams building worker services and they all had to talk to the team for that publisher service and say, please integrate by making an API call to our service to feed us this event. Well, that's just not going to work out. Like, that publisher team is going to be slammed with requests and stuff's going to be breaking constantly, versus now the publisher team can just can create one integration to push the event to SNS, and they're done. Every other team is now unblocked and can start consuming that event out of SNS into their own SKS queue as needed.
And you can do that through AWS Copilot, which, again, as we were talking about a few announcements ago, is you still get to be the pilot, but you have this AWS Copilot, which is a CLI tool that helps you get started by generating manifest files, generating CloudFormation templates, and helping you really figure out I don't want to say infrastructure. It is infrastructure, but it's also the infrastructure as code that's needed for your application architecture, whether it's that worker service, that web service, in this instance now implementing that pub sub architecture. And you can do all of that very easily with a few commands using AWS Copilot.
Yeah, it's the best practices too. Like, for example, the Copilot pattern for implementing the queue consumer, which is what you see on the right-hand side, has built-in rules that you can configure for the scaling. So if there are a lot, somebody requested a Zoom. Yeah, there we go. If there's a lot of events coming in and hitting the queue, they could start backing up in the queue. So the Copilot pattern for the queue consumer will set up scaling rules to automatically watch the depth of items on the queue and scale out if necessary to increase the number of tasks that are working on items from that queue. It implements, I believe, retries and dead letter queue by out of the box. And the other thing that's really cool in this article is they talk about how to set up a filter. So let's say that
you have that filter policy.
Yeah, that upstream team is just going to publish to the SNS topic every time the event occurs. But you may not necessarily be interested in every event. You only want events that match specific criteria. And so Copilot will also help you set up that filter policy out of the box too, right there in an easy to understand YAML format.
Yeah, and you can see kind of the different YAML snippets. This blog post actually super helpful, because if you are curious about how you would get started with this is actually one of the how-to and walkthrough blog posts where we'll actually give you a sample application and allow you to really get started with understanding these concepts. I find that everyone learns differently. Some people love reading blog posts, some people love watching videos, and some people love doing. So this kind of has the best of both worlds, where we'll actually give you the code itself, and then you can walk through and learn how to set this up. Again, using Copilot, so you're not having to write all of the stuff manually from scratch. And here's the filter policy. You can start to see how that's being defined in your YAML in that manifest file.
Yeah, it's pretty cool. So it's basically saying, I don't care about any order that's under $80, but any order that's over $80, this particular microservice is interested in that, and it really wants to know about that order and respond to it in some way.
Absolutely. And we actually have a Agile Guru who's asking for a link to the blog post. We will make sure that links to all these blog posts are in the description after the show. But in the meantime, we went ahead and just linked that both on YouTube and on Twitch. Thanks for that assist, Nathan. I'm going to go ahead and show that on the screen. So you can definitely check out aws.amazon.com blogs and then implementing pub sub architecture with AWS Copilot. That's definitely a fun one, especially for developers, but especially for people who are looking to kind of simplify how to get started with creating that, again, as opposed to having to write that type of architecture from scratch. Our next announcement is application integration patterns for microservices, which focuses on fan out strategies. And this is actually part of a series blog post, which is pretty interesting. Again, we're using that wild rides again. So that graphic just gets me every time. But yeah, application integration patterns. So we can kind of scroll down. Again, we're kind of seeing how you could submit a ride completion using Unicorn Management Service. We're, again, focusing on that same application. So as you're going through the series, definitely check that out. But Nathan, thoughts on this particular announcement?
Yeah, so I think fan out is the sort of sibling to the pub sub,
Right.
whereas pub sub you have a sort of a one-to-one relationship between each of the subscriptions. Fan out is sort of like, I want to replicate this thing out to everybody on this particular list. I personally kind of like pub sub better because I have the queue there in the middle. But fan out could be appropriate as well when you want to synchronously sort of ensure that this event gets pushed out right away to everybody who's subscribing to an SNS topic. And so the SNS will, with one call, make many calls to each of the downstream people that have subscribed to join that sort of fan out and receive that synchronous API call. So that can make a lot of sense because, as I mentioned before, let's say there's 50 different downstream teams that want to receive this particular API call or this particular event.
Right.
Whenever the event happens, I don't want to implement 50 different HTTP calls out of my upstream application. I can just talk to SNS once, and then SNS will handle the fan out of all of that stuff to the downstreams. Now, whether that goes into a queue or whether it goes synchronously, it can go either way. So I think generally when you talk about fan out, you're talking about SNS making a synchronous API call. As soon as the event comes in, it synchronously calls somebody else's HTTP server. Whereas the pub sub is, it goes into a queue first, and then that worker can pull work off the queue one by one as needed.
And that's pretty awesome too. That's it depends on, again, your architecture and what your needs are. Like as Nathan was saying, like he kind of prefers pub sub, but there's definitely scenarios where fan out makes sense. So being able to have that, I think, is super helpful. Our next announcement is Bottlerocket adds support for FireLens. Now, Bottlerocket is a Linux-based operating system that was designed to host container workloads. And now you could support FireLens, which again is a container log router for ECS, which allows you to easily send logs to multiple destinations. So it really gives you that extensibility for your ECS. And you can start, if you're already using Bottlerocket already, as long as you're using version 1.13 or higher, you can now start using that feature.
Yeah, I'm glad and happy to see Bottlerocket getting more and more support for the full set of ECS features. It's still not 100% there. We can't do everything that you can do with ECS on like Amazon Linux, but this is another step toward making sure that Bottlerocket has that full support or coverage for Amazon ECS features because they are very committed to it. I think that Bottlerocket as a Linux-based operating system is truly unique in some of the ways with how it treats containers, and it's well positioned to be a more secure alternative than sort of gluing together container support on top of an existing general purpose operating system. So always very interested in getting more feedback and seeing where people adopt Bottlerocket. And if FireLens was a blocker for you because you really like FireLens, now it no longer is. Now Bottlerocket has support for FireLens.
Yeah, we removed the blockers. And I mean, if you want to get in contact with the Bottlerocket team, if you want to reach out and chat to anyone, you're always, of course, welcome to reach out to Nathan, myself, or anyone on the ECS team, and we can help direct you and kind of be that human router. But you can also open a new issue on GitHub and communicate with the Bottlerocket team directly that way as well. Like we said, we love hearing that feedback and having comments, suggestions, things that you'd like to see. But this is a big one as well. If FireLens was that blocker, now it no longer is. And our final announcement for today that we have is break up the monolithic application into microservices. And you can do that with AWS Copilot, ECS, Docker, and AWS Fargate. And this tutorial has now been completely updated. So this...
Yeah, I originally made the first version of this tutorial almost like 5 years ago. It was, I think, before Fargate. It was before Copilot. It was before a lot of different things. And at that time, there wasn't really like there was, from what I saw, an understanding of the strangler pattern of microservices. But people didn't really know how to do the strangler pattern on top of AWS. And so what I wanted to do was show how, with the freshly launched application load balancer support, you can easily have one load balancer that splits off a specific REST path and says, I'm going to send that REST path to this other microservice instead of to the monolith, and gradually break off that one path one by one out of the monolith into microservices. So now it's freshly updated. We got the latest and greatest command line tools. We got Fargate in there. This is going to feel it's still a legendary classic pattern, a strangler pattern of how to break up a monolith into microservices, but just more modern tools to use.
And the best thing is if you are curious, out of all the conversations I think I have with customers, probably one of the most common topics, especially when you're talking to customers who've been doing this a while, and they're more what I guess now we call like legacy customers, but trying to figure out how you're going from your traditional legacy or monolithic architecture to this more cloud native or microservice type architecture, it's a very daunting task. And trying to like at least have some sort of tutorial that walks me through that slowly and with a sample application so that it kind of makes sense is super powerful. And my favorite part about this tutorial being updated is, number one, it takes less than 2 hours to complete to try to understand, but it's also free tier eligible. So if you are new to AWS, using AWS, and you are eligible for the free tier, you can be able to run through this complete tutorial for free. The requirements are very simple. You just need your AWS account to install and configure your AWS CLI and Copilot, Docker, which if you are moving from that monolithic architecture over into microservices, you are going to need a container runtime. Docker, I think, is still probably the most popular. And then a text editor. And for this tutorial, they'll use VS Code. That's my personal preference for text editor, but you can use the IDE of your choice if you want Atom, Sublime, or whatever from there. But this is something that I'm really excited about because it is probably one of the most common conversations and topics.
I actually have I'm actually not sure whether it's free tier eligible. We might need to fix that.
The problem as I just went off on that.
The problem being that unfortunately Fargate doesn't have a free tier yet. Always happy to hear feedback on that. So if you really would like to see a Fargate free tier, please hit us up on that. But I think if you do deploy this on top of EC2, you will be able to deploy it completely free, provision too large of an EC2. But so unfortunately, it's a little bit inaccurate. I'm gonna have to get the folks to update that because it may not be free tier eligible when you deploy it on top of AWS Fargate.
But again,
if you have any credits, it probably will fit in top of your credits for very, very cheaply.
That's good to know. But again, if you do want to use ECS, you could still get started with EC2 to understand more so the bigger principle of breaking up that monolith into microservices and decoupling. So you'll still be able to learn the lesson, and then we can deal with Fargate at a later time. That's a good catch from Nathan. I apologize for misrepresenting that.
No, it's fine. It's fine. It's a common thing I see people ask, like, does Fargate have a free tier? And unfortunately, not quite yet. But as I said, we have an open roadmap, and there is an issue on there if somebody's asked for an AWS Fargate free tier. So please look that up and upvote it if you'd like to see a Fargate free tier, and that'll help us prioritize getting that onto the official roadmap.
Yep, absolutely. And you can see, I mean, I love even like these simple, I mean, they're very simple, but I love the simple like graphics that are kind of explaining as rather than having all your different APIs as one monolith, like we'll show you as part of this tutorial how to break that up and how to actually decouple that into the more cloud native or microservice architecture. Whew, that's a whirlwind of various announcements. Like I said, 7 different announcements. And I apologize earlier when I did click on the fan out. that was actually a reference link from the PubSub architecture. So PubSub is building on top of that. The fan out was not new. PubSub implementation with Copilot was new. So many different announcements. Sometimes it's hard to keep track. I know there was a few people, Agile Guru on YouTube and Kritsikio, I hope I'm saying that correctly, on Twitch. Both wanted the articles linked. We will make sure that they will be in the description on YouTube, and making sure that, I believe if we can also add those anywhere on Twitch. Everything that we have talked about today, we'll make sure that we have links for that. So that you can be able to go check out these announcements on your own. And please, if you also have feedback, whether that's the monolith, whether that's Bottlerocket, or anything we've discussed today, reach out and talk to Nathan and I. If you want to talk directly to any of the teams, or have any questions, we can definitely help facilitate that as well and get you answers accordingly. Like I mentioned, the human router. Nathan, do you have anything else to add for today?
No, I think if anybody has any last minute questions, feel free to drop them in chat. But other than that, I hope you all enjoy some of these latest releases and blog posts and articles about ECS. I hope it helps you to build amazing things on top of ECS and make your ideas come true. And feel free to reach out if you have any more questions or concerns or feature requests for ECS.
Yeah, absolutely. And again, thank you for hanging out with us today. This is part of our monthly roundup for ECS, where every month we hang out, we get together. Sometimes it's a couple of us, sometimes it's more. This is leading up into a holiday weekend, so we do appreciate everyone who took the time out of their day to join us. But we will be back here again next month, where we'll talk about everything that is happening currently in the month of April. So can't wait to see all the announcements there. But we come here every month to hang out, chat. And even as Nathan said in the beginning, where we're also here to answer any questions that you may have as it centers around containers, ECS, AWS, and we can help you get started with your AWS journey and build those amazing things. I think we haven't had anybody drop any questions or comments, but if you do, you can reach out to us. Both Nathan's and my handles on Twitter are linked in our video description. We'll make that a little bit bigger right now. So you can see at JL Dean or at Nathan K. Peck. And again, we'll be happy to connect with you and answer any questions you may have. All right. And with that, we are going to say goodbye. And,
thanks a lot, everyone.
Thank you.